everyone, welcome to this session on Amazon Document DB Deep Dive. My name is Vin and I'm a product manager on the Amazon Document DB service. I am super excited to be here today to talk to you about Document DB and share with you what we've been working on over the past year. And also joined with me is Daniel from Rappi, who's going to be sharing with you later on how they are using Document DB. So for our agenda today, we're going to roughly divide this talk into 4 sections. In the first section, we're going to be talking about what Document DB is, and then we're going to get into its architecture. And as I explain the architecture of the service, I'll also explain to you what this means for you and how you can get the most out of the service. And in the third part, I'll share with you what we've been working on, as well as how you can take advantage of the latest features. And in the last part, we'll have Daniel, as mentioned, share with you on their journey and how they've been using Document DB at Rappi. So with that said, let's get into the first part of our presentation. So what is Amazon Document DB? And in a single line, if I only had 15 minutes with you in 15 seconds with you in an elevator, I would tell you that Amazon Document DB is a purpose-built database for JSON data management at scale, and it's fully managed. So what does that mean? So let's take a look at some of the characteristics, main characteristics of this service that we just mentioned. So that further explains what this service actually is. Starting with the very left, we're going to start with scalability. So with Document DB, you have the ability to scale your compute both up and out in minutes, and we'll dive a little deeper on these topics when we go into the architecture. With the service, we also scale the storage for you automatically up to 64 terabytes, so you don't have to worry about managing that storage. And this service also enables you to provide you up to 16 replicas for reading, which enables you to perform millions of reads. And the last point here I'd like to call out is that we have a new feature called Global Clusters, which I'll cover later on when we discuss features, which makes Document DB clusters globally distributed. And we'll cover what that means, as I just mentioned. The second characteristic on this slide is fully managed. With Document DB, we are going to handle a lot of those administrative tasks for you so you can focus on your application and building out your app. And so out of the box, what we provide for you is built-in high availability, backups by default, durability by default, data durability, as I just mentioned, as well as security best practices by default as well. So for example, we actually enable encryption for you when you create a new instance or a cluster on the service. And we do that because we believe that this is the security best practice to have encryption enabled. With the service, we also have automated patching and monitoring and alerting built in as well. So you don't have to do those things separately. And the last characteristic I like to cover here is MongoDB compatibility. We have a lot of customers whose applications use the Mongo API for the workloads, and they've been able to adopt Document DB with little or no change to the application or their drivers as well. Now, our service supports hundreds of APIs, but the most important thing I like to call out here is that we're constantly working backwards from the needs of our customers. So we've done this since day one, since we built this service. We've done this over the past year, and we're going to continue to do this, constantly working backwards from our customers' needs. Now, all those characteristics sound great, but when should you actually use a document database? If you're working with JSON data, that's a good indicator. Another big indicator is whether you need flexible schema. If you need flexible schema, or you don't know upfront what your schema is going to be, or you know it's going to evolve over time, Document DB may be a really good choice. With Document DB, you also have the ability to perform ad hoc queries and create flexible indexes even as your schema evolves over time. And in addition, and the last point I'd like to call out here is that in addition to those operational workloads which you would use this database for, there are also many powerful built-in operations where you could filter and group some of the data for those analytics workloads. So here's an example that highlights some of those points earlier, and I really love this example because I'm a little bit of a video gamer myself. So taking a look at this gaming user profiles, you can see here I have a profile with Susan. And let's say Susan plays a new game called Exploding Snails. we can easily add this information to her profile. And notice here, we didn't have to design any complicated schema or create any new tables. We simply added a new set of fields to the document. And we can continue to evolve this document. For example, including the array of promotions that Susan's just achieved when she's playing this game. Now, so this document model really enables developers to evolve their applications quickly over time and build applications faster without worrying about all that schema that they have to do upfront. So who uses DocumentDB? Now, in-house Amazon does use this product, but so do many of our other customers across other industries. Now, and these are just a few of the customers, and I couldn't list all of our customers onto a single slide, but here are just some of them. Now, if you go to our customers page in our documentation, you can see what these customers are doing and what they're saying about the product. So, all right, that's what DocumentDB was in a nutshell. All right, so in our next section, we're going to dive deep into the architecture of DocumentDB, and it really starts with this question: how is DocumentDB architected for NoSQL workloads at scale? So to answer that question, we really work backwards from our customers by taking a look at their scale challenges. Now, if you take a look at a traditional architecture, the database stack is very tightly coupled as a monolith, making it really hard to scale. And to illustrate that, let's take a look at a few examples. So let's say you want to scale out your reads. You know in advance that you want to run quarterly reports, so you anticipate an increase in traffic. So to scale out your reads, one way you could do this is to provision another instance or multiple instances and copy that data over. And this primarily has two big problems. If you have a large database, like a lot of data, copying this data is going to take a really, really long time. And we've had customers tell us that adding a new node can take hours, days, or even weeks just to add a new node. So that's the first challenge. A second challenge is that this may impact the active workload on the primary as well, because that primary instance now has to be involved with some of that replicating of the data over to the new nodes. So similar problem here with another example is recovering from node failure. Let's say this instance were to fail. Now, if you have a lot of data to sync over to a new instance, then it may be a very long recovery time, and potentially this may also impact that primary instance. Now, in addition to these 2 points, I'd like to also call out that, setting up and monitoring a high availability solution also takes a lot of effort. So that's also another downside. So when designing DocumentDB, we asked ourselves, how can we design this service for the cloud? How do we solve some of these challenges that I just mentioned? So the first thing that we did was to separate out the storage and compute into two distinct layers, the compute layer and the storage layer. And by doing this, we allow the compute layer to primarily serve your workloads. So it's going to perform things like processing queries, caching, handling API calls, and then it's going to push those log writes to the storage subsystem, where the storage subsystem is going to handle the page flushes and constructing some of those page images so that the compute layer does not need to spend cycles doing those things. And the storage layer is also going to do a lot of the heavy lifting around data replication and durability. So by doing this and separating the two layers, this ultimately also enables us to scale the compute and storage separately. So let's take a look at how this system scales and how this architecture enables us to scale these two components separately. So in this diagram, I have a T3 medium instance, a very small instance, great for dev tests, and it's connected to our storage subsystem here. So let's say I need to scale this instance up. Now, because this instance is not data bearing, and you can see that the storage is decoupled, I can easily replace this instance. So let's say an R5 large, and it'll be ready to go in minutes. I didn't have to move any data, and so this process is fairly quick. Now, going back to the scenario I just talked about, let's say we anticipate the need to scale out our read workloads. So we could easily add another instance to this cluster. And again, note that there's no need to copy any data over, and I'm not taking any resources for that replication of data from my original primary instance here. And in fact, I'm going to actually demo this scenario later on, just shortly. Also, I can scale up the instances of my cluster independently if I wanted to, or I could scale all of them at once. So I could turn from an R5 large to a 2x large, and I could do that across all the instances. And in fact, the storage and compute is so decoupled, I could delete all the instances. And in fact, if I, for example, let's say I have a developer environment, I want to just scale down completely at night. This is very possible, and your storage and your data is still there, highly persisting all your data. And when you're ready, you could add your instance back up, and it'll be ready in a matter of minutes. So in the next section, we're going to be sharing a demo here. And what I'm going to be doing in this demo is add 3 more instances to my cluster while there's a workload going on. So notice here I have a single instance. It's called test cluster 9, and it has this. Our cluster only has one instance, a small T3 medium. Now what I'm going to do now is kick off a workload, and this is going to target our instance, test cluster 9, and this workload is going to report back the number of operations per second every 10 seconds, and we're going to see some activity here. So notice that there's some activity here, and so I like to also call it that we're not trying to benchmark anything or focus on the performance. What we're really trying to do is just see that there is a consistent set of operations per second as we add additional instances. So you can see here, it's about 9,000 operations per second. It's about 8,000, 9,000, low 9,000s. And what I'm going to go do now is go to the console and add 3 additional instances to our cluster while there's a workload running against it. So here, I'm going to press create. And I'm going to create 3 additional instances. And I'm going to add 3 additional T3 mediums just to be homogeneous with my original primary instance. I'm going to hit create. And back on the dashboard, I should see that these instances are going to be in a creating state. So let's go do that. So you can see here now that I have 3 additional replica instances in the process of creating while there's a workload running against my cluster. So let's go ahead and go back to that cluster and see what this looks like. So you can see here that application is still running against it, and there's still approximately 8,000, 9,000 operations per second. So there's no impact to my cluster with that workload while I'm adding additional instances. So let's speed this up a little bit, and I should at some point see some form of change. So here, notice that all of a sudden there is about 15,000 current operations per second. So this is an indicator that something has changed in my cluster for the purposes of this demo. So let's go back to the database document DB console to see what the state of these instances are. So here I can see that I'm going to refresh it, and I can see that it is configuring some log exports. So actually at this point, the instances are actually up and running. We're just configuring some last steps for the purposes of monitoring these instances. And in fact, what this application is actually connecting to some of these replica instances and now running some workloads against it as well. So you can see that throughout this process, there was no impact to our performance. And at some point, once these instances were fully available, you can see that it is now using these replica instances as well. So let's go back to our presentation. So yep, we were able to scale up the number of instances without impacting our workload while that was currently running, and we also didn't need to copy or move any data as well as we added more instances. Now let's take a look at how our architecture handles replication. So another advantage of the document DB architecture is that we're offloading the replication from the compute layer to the storage layer. So when you perform a write in document DB, it goes to the primary, and that primary is going to write that down to the storage layer. And that storage layer is going to replicate that write to 4 volumes as animated here. And once it has completed making those 4 copies of the data, it will acknowledge back to the client that that write was indeed durable. And after we have acknowledged, we're going to continue to make 2 additional writes for a total of 6 copies of your data. And the reason why we write 4 copies before communicating back to the client that the write was durable is because when we have a total of 6 copies of data, the write quorum is actually 4. Now, one thing I like to call out is that the replicas in this cluster, notice on the 2 sides of the primary here, are actually not participating in this replication process, which frees them up to actually do writes. Now, one of the best practices that we tell our customers is to connect to the DocumentDB cluster with a replica set. By connecting to your cluster as a replica set, we actually enable the client to discover the full topography of the cluster automatically. So the application will actually know which instances in your cluster are actually a primary and which ones are actually replicas. And this is advantageous because what this further enables you to do is set another parameter in your connection string known as read preference, and you could specify secondary preferred. And what this is going to do is push those read workloads to the replicas as opposed to having it on the primary, so that the primary can focus on writes. In fact, this is actually what we did in our previous demo, where at some point you noticed that our operations per second started to increase. And this is because the application was able to discover the multiple replica instances that could be used for those reads. So notice that I went from about 8 to 9,000 to 15 to 16,000. And one thing I like to also call out here is that reads are eventually consistent. Now let's go on and talk about durability. So we already mentioned that we copy your data 6 times across 3 availability zones. So let's actually walk through a scenario on what this means for you. Now, let's say an entire availability zone goes down. What actually happens to your DocumentDB cluster? Since we store 6 copies of your data and there are 2 available in each availability zone, we still have 4 copies of your data. So you're still good to do both reads and writes because the write quorum is 4. Now, in a super unlikely event that a storage node goes down, what happens to your database? Now, while these 2 events are completely independent, it is still possible. Things like this, things can fail at the same time, although super unlikely. Now, at this point, you'll lose write quorum, but you still have read quorum, and you can still read from the database. So you're going to ask. So at this point, you might ask, well, how long is it going to take me to recover? How long until I can start performing writes again? So this is actually a function. The average recovery time is actually a function of how long it takes to replicate 10 gigs of data. What we do in DocumentDB is that we actually split up the storage volume into 10 gigabyte partitions. So rehydrating a 10 gigabyte data partition over a 10 gig link, for example, is actually really fast. So this is actually another really big advantage of distributing the storage as opposed to having a single monolithic disk volume, so that the recovery time is actually just degrees faster. So that was the architecture. Hopefully that information was insightful and helps you take full advantage of the scale characteristics of DocumentDB. Now let's get into what's new. I'm super excited for this part because I get to really share what the team has been working on over the past year. Now, we've been working across many different areas, across performance, tooling, API, security, and so much more. And what I'm sharing on this page is just a highlight of some of the recent features we've added to DocumentDB. And there's, again, like to really emphasize so much more. Now, I'll come back to this slide in a bit, but let's dive into some of the details of some of these features that I'd like to highlight. The first feature I'd like to highlight is global clusters. With global clusters, it actually enables you to replicate your data from one primary region, a primary cluster, to a secondary cluster in another region, as noted in this diagram. So notice here there's a primary, noted with P, and a secondary cluster noted with S. And they are across different regions. And this enables you to replicate data across up to 5 AWS regions. And in each cluster, we enable you to have 16 replicas so you can scale out your reads. And we actually leverage storage-based replication as with the theme before. So there's no impact to the instances of your cluster, and the latency is typically less than 1 second across clusters. And one thing that you could also do is promote any of the secondaries to a primary in a matter of minutes. So what are the primary use cases? When should I use this? First, if your application or industry has requirements that you must be able to recover from a region failure, you can leverage this feature and promote a secondary cluster to become a primary in minutes. Second, you can also use the secondary clusters for global reads with local latency. For example, let's say you have a retail chain that spans across multiple regions. What you could do is update the prices in your primary region and then leverage global clusters for those reads in those secondary locations. Now let's get into how easy it is to enable global clusters on an existing cluster. So here I am in the console, and I'm highlighting the second row here. And notice the role of the cluster in a region is actually a regional cluster. So here you can see that I'm selecting the second row. It is currently a regional cluster. Now, to convert this into a global cluster, I would just have to select this cluster and click on Add Region under Actions. And upon clicking this, it's going to bring me to a form that's going to enable me to choose where my secondary region is. So in this example, I'm going to select US East Ohio. And also, I'm now also going to specify the name of my global cluster, because before it was just a regional cluster, and now I'm converting this to a global cluster. So here I'm going to call this global cluster demo. And the cluster identifier, which is the name of our secondary cluster, I'm just going to leave this as a default. I would specify a name in here as well. And then I could also specify the instance class and the number of instances I want to as well. And once I've done finishing filling out these 5 fields, I can click on Create Cluster. So going back to our clusters view in our dashboard, you can see that we now have a new global cluster. So look at the second row here. You can see that the role of this is now global cluster, and it spans across 2 different regions. So our original cluster, or regional cluster, is now known as a primary cluster, and it's in US East 2. And we also have now a secondary cluster located in US East 1, and it's currently in a creating state. So that's actually how easy it is, just by filling out 5 fields on a form to convert a regional cluster to a global cluster. Now, jumping gears a little bit, another area we really like that we've been focusing on is connectivity and drivers. The main point of this investing in this area is that we really want to enable applications, different types of applications, to connect to DocumentDB. So earlier this year, we released the JDBC driver for DocumentDB, and this is going to enable you to connect to DocumentDB as a data source for those business intelligence tools, such as Tableau, MicroStrategy, QuiltView. And these are just an example of a few of the tools, not a complete list. With the JDBC driver, we also enable you to run SQL queries against DocumentDB from tools such as SQL Workbench. And the last thing I like to call out is it's open source. We actually open source the JDBC driver, so you can actually go check this out on GitHub, and make requests where you see fit, as well as potentially contribute in the future, and we would love that. So here's a screenshot from Tableau. Now, once you've installed the Amazon DocumentDB connector for Tableau, you can click on Connect to a Server, and under More, you can now see Amazon DocumentDB as a choice in which you can select. So upon selecting this and filling out the necessary connection information, you can now use Tableau to query and connect to and query DocumentDB as a source. So here, I'm connecting to a movies collection, as you can note here, and I can continue to use Tableau as I normally would to create business intelligence dashboards. So here I have a very simple dashboard of actors in movies. And as I mentioned earlier, you can also, with the JDBC driver, we also provide a SQL interface. So here with the same movie collection, I am able to run some SQL against it. And upon issuing that query, I can also get results as if I'm just running a SQL-like database. So going back to the highlights from last year, we just showed what we just quickly breezed global clusters and the JDBC driver, which is the second and fourth item on this list. But I'd also like to call out a few more things. We also released Graviton instances, as noted on the first line here, and this provides you with up to 30% better performance for the same type of instance that you'd be using before. So those T and R5 instances, you can convert to using Graviton instances and get up to 30% better performance. We just talked about global clusters, which enables you to have a more of a global footprint with your data. The third item here is role-based access control with user-defined functions. So this is one of those security features a lot of our customers have been asking for. Earlier this year and prior to user-defined roles, we enabled you to use system-defined roles for role-based access control, but now you could define your own roles for accessing DocumentDB. And we talked about the JDBC driver, which provides you a SQL interface as well as connection to BI for those analytics purposes. And the last thing I'd like to call out is we also enabled geospatial querying capabilities, which was another really big ask for our customers, as well as many additional Mongo APIs, which I couldn't even list on this page. In fact, couldn't even list a lot of the features which I would have loved to share with you today as well. So to get the latest, do go check out our documentation as well as our release notes, and stay tuned on some of the blogs as well so that you can get the latest updates on what we've been working on. And with that said, I'm going to hand this over to Daniel from Rappi, who's going to be sharing with you how they've been using DocumentDB. So over on to you, Daniel.
Thanks everyone for attending. My name is Daniel Guzman Burgos. I am the head of data at Rappi. Before going deep with the DocumentDB case in Rappi, let me introduce Rappi to everyone. Rappi is the first Colombian unicorn. Was founded in 2015. Rappi is a multi-vertical tech platform that connects commerce, consumers, and couriers, allowing to deliver almost anything from food, clothing, to insurance, to financial services, and many other more. Rappi operates in 9 Latin American countries in more than 250 cities. So, all right, let's now talk tech. Being a multi-vertical platform means that the data it's also multi-business with its own particular requirements. At the data team, we need to follow business in terms of flexibility, scalability, and performance. We cannot be the bottleneck. We cannot be the one that slow the growth, right? So that being said, it's worth to mention that with a small team, back in the day, we have to be able to manage hundreds of databases on different storage types, not only document databases, but relational databases, and also graph databases. So where were Rappi before DocumentDB? To put everyone in context, so we were operating with several MongoDB replica sets using Percona server for MongoDB on version 3.6. We had pretty heavy constraints with this type of operation. First of all, we were working at full capacity on the instance size. We were using Amazon EC2 instances, all of them at 16x large size. This is pretty much to avoid dealing with scaling, and it was a huge cost. We have lack of a proper backup solution. heavily rely on the EVS snapshots. So in other words, it means that we didn't have logical backup. So it was all of nothing in terms we need to restore. We didn't have that much flexibility on restore specific collection or stuff like that. Our monitoring was limited to metrics exposed by Amazon CloudWatch. What does that mean? We only had metrics for the instance in itself, CPU, memory usage, stuff like that. We didn't have eyes to insight what's going on the MongoDB. There was a huge risk. We were aware of that, but we were dealing with that. And any log profile, any log analysis was made ad hoc. So it was just from time to time, very manual stuff, very time consuming and not that efficient. So to summarize the challenge, it was a small team, way too small for way too many databases on different storage types. And the key parts of the problems were the lack of MongoDB knowledge, the lack of Linux knowledge, and other pressing priorities dictated by the business that we have to manage. And that way, our technical debt was growing and growing. And not only our technical debt, our cost was huge. It was not possible for us to perform easily, scale up, scale down. The performance optimization were not part of any of the daily to-day task of the DBA. So we pretty much found ourselves realizing that something needed to change. Inside Rapid Document Store was already a big thing for the developers and the app itself. We already moved out from Elasticsearch to MongoDB replica sets, but we were dealing with the changes that I already mentioned. So Rapid started to look at the partners that it has. Found out that AWS had this DocumentDB. And that's what we needed for many reasons, but specifically for the fully managed services. And it was already MongoDB compatible. We're not trying to move to a different technology for document store. It was just the same old MongoDB compatibility. How was the migration? To our surprise, the migration was pretty straightforward. It took weeks, not months. We do expect some long migration process, but that wasn't the case. And this record time was possible mainly because no code need to be changed. Nothing has to be rewritten. And that was because DocDB already supported all the MongoDB features that we were using it. So it was pretty straightforward. By moving to DocumentDB, we immediately see benefits on things like latency and the disappearance of outage and downtime issues that always hurts the business. So by moving DocDB, we face immediately benefits on things like latency and outage, or should I say, the lack of outage. Our current situation with DocumentDB right now is that we have a fully managed services and everything that comes with it, a backup solution that we don't have to maintain or upgrade or add alerts or stuff like that. It's everything managed by AWS. We can now size the instance according to the load. Being was just mentioning that a good practice or something that you can do is to scale down the replicas when there's low traffic, which in our case it's um, starting from midnight until the early morning. We do that. We do scale down everything and just scale up before traffic start to kick in. That's a huge cost saving for us. It's fantastic. Uh, we don't need anymore an arbiter uh, like we do have the necessity on MongoDB replica sets. Failovers are super easy. Failovers are just a matter of uh, clicking a button or sending an API call. So you can just easily script that. Uh, Scaling up and down is no brainer, like I mentioned. We do have login sites out of the box through CloudWatch. That it's fantastic. I'm just gonna show you some screenshot of how that does look in a bit. And we do have more integrated CloudWatch metrics, not only on the instance level, but we do have inside metrics, TTL indexer, uplogs, cursor, stuff like that. We also have continue to have the 128 clusters, but only on DocumentDB. Why? Because DocumentDB runs key business features. To give us some examples, the restaurant catalog, which is one of our bigger verticals, runs through DocumentDB, and thanks to DocumentDB. The app home also served through DocumentDB and also some fallbacks, but mainly DocumentDB. Is the same for the store catalog or CPG's vertical. Also relies heavily on DocumentDB. So it's a critical part of our system. Some of this is a list of some of the things that we have. The clusters that we have, everything is regional cluster. It's still 3.6, but we didn't need to upgrade yet. We're just gonna do it eventually, but we still have full performance, all the capabilities for scalability and high availability. So no problem with that. This is how the log insight profile looks like. It has its own graphics. You can just run some special queries over these logs. The DocumentDB and actually the CloudWatch documentation is full of those queries where you can just find out things like queries that are using cold scans, queries that are taking way too much, specific like let me show me the updates that are taking more than 300 milliseconds is in there. It's fantastic. It's embedded. It's part of the deal. Also, like I mentioned, metrics from CloudWatch, metrics that you can add mathematical expressions or things like anomaly detection that you can integrate CloudWatch with simple notification service and just get alerted on anomaly covered by DocumentDB. So in conclusion, we just have to say that it's a change from night to day or day to night. We practically have zero outage with DocumentDB, except for some things that just happen normally and suspected on every club vendor. We migrated the complete amount of MongoDB in the lack of 3 months, but the critical ones took us 3 to 4 weeks. That was pretty impressive. Like I said, decrease on latency, the operational overhead was reduced. We do have a slightly bigger team, but all this increase of resources or DBAs, I can use it elsewhere. I don't need to dedicate that force to maintain something because it's already maintained, it's fully managed, by AWS. And we have very similarly and very good relationship. We work like partners. Amazon welcomes and campaigners through all the challenge or things that we need to would like to have in DocumentDB. It's very okay. Can I start again? Okay. Amazon welcomes and accompanies us on feature requests, improvements that we have, or questions of anything on DocumentDB. So it feels really good. And that's it. That's the rapid case. Going back to Bean to wrap up some of the things and finish the talk. So Bean.
All right. Thank you, Daniel, so much for sharing that with us. It's also been an absolute pleasure working with you and seeing the journey of Rappi and seeing the business grow over there as well, and your journey to adopting DocumentDB. So that brings us to the end of our presentation. Thank you all again for your time and joining us on this session. And I'm looking forward to seeing you all very soon. Thanks.